So if I am audible, I guess it's time for us to start. So this is the money section, and we are going to be looking into the following questions. So guys, I hope you can see the questions. I'm still trying to work on the camera quality and stuff. Can you guys see me? You can drop a message. Okay. Okay. Not that clear. All right. Okay. Some can see me clearly. What about the questions? Can you see that? Excuse me. So fine. Yeah. So if you can see, I think I can start. So we have the first one. We are to give the name and the nature of the radiations that are emitted during radioactivity. I believe that is kind of cheap for us, if I am right. So basically, the radiations are what we've discussed before. We talk about the alpha radiation, the beta radiation, and the gamma radiation. So you just write that. You can write it because sometimes spellings matter. Alpha, beta, and gamma. And please be careful about the sign. If you are using the sign is also another important thing. So if you know how to draw the sign, you can go by that too. So there are two things. These are the name, the nature, which is most importantly. This is the same thing as helium. Alpha is called helium particle. We've discussed that. They are deflected towards the negative side. Beta is called the electron. And the nature of gamma ray, and they are not deflected. There are other nature or characteristics you can talk about, as these having the highest penetrating power, and these alpha having the lowest penetrating power, and so on and so forth. So we can see the second one. Some are saying they are not seeing. I'm seeing your messages. Okay. Oh, fine. Some are saying they are not seeing. Please, I have the recorded version you guys are going to watch. So let's quickly move to the next one. 1AII. You are to state the differences between chemical reaction and nuclear reaction. So, okay, fine. So just two differences. You can just write or make it in a tabular form, like I'm trying to do, and write in terms of some simple things I believe you can know. We talk about nuclear reaction, you talk about chemical reaction. In chemical reactions, we talk about let's talk about the first thing, which I think is so simple. Let's say factors like temperature, pressure, catalyst, and so on and so forth affects the rate of reaction. So, but in the other one here, all these factors, all the factors mentioned, you are to write it well, do not affect the rate of reaction. So I believe you can see that. So that's one. You can also put another one, which I think is also basic. When you talk about nuclear reaction, you're talking about heavy nuclear, so it's involved high energy is required for reaction to take place. So on this one, you can talk about low energy is required. Excuse me. So you can also talk about other things like these only involve electrons, only what are colliding with each other and are coming together to react. But in nuclear energy, you talk about the molecule itself are also taking part in the reaction. So far, it is just two. And I don't want us to waste time because we still have a long way to go. So we can go to the next one. We have to balance the following nuclear reaction. So we just look at the position. We've talked about alpha, beta, and gamma. Can you guys hear me? Okay. So here you can see the first reaction. You have 21284 PO is polonium, and it's giving us 20882. That is lead. So you can see the differences from 212 to 208. So this is decreasing by 4. And the same thing here, 84 to 82 is decreasing by 2. So that is just the balance, and that shows helium or alpha particles. The second one is cesium is 137.55. Can you see these guys? And the atomic mass remains same, but the atomic number is increasing by 1. So this is 0, and this is -1. So this is beta, or your helium particle, or your beta particle. So that is that, and that is your 12 marks. Like I said, chemistry is not difficult with constant practice. So let's check out the B question, the B part of the question. About the B, we have the electron configuration of an element X is this: 1x2, 2x2, 2p6, 3x2, and 3p5. We have to deduce the atomic number of X. So to get atomic number, all we need to do is just to add all these powers here. So it makes it very simple. So we say 2 plus 2 plus 6 plus 2 plus 5 should give us 17. So we say atomic number of X is 17. It's as simple as that, you can see. So the next here is to what group does X belong? We've talked about periodic table. So, and we talk about group 17. You can write that in the old school configuration as 2, 8, 7. So, and I told you when you do that, you use the valence electron to get the group of that element. So, and again, if it is the modern periodic table, I say you are going to always add 10 to it. That is that. So this belongs to group 7. But in modern periodic table, we say group 17. So I hope students understand that. So yeah, it's also very simple to know this, as this is a group 7. You can just write group 7. We have to give two properties of the group to which the elements belong. So about group 7, which is Mendeleev periodic table. Can you guys hear me? Some are saying they can't see me clearly. Okay, let me adjust the position of the camera. How about like this? Can you guys see me? Oh, fine. Not clear. Oh, fine. I will still adjust that. So let's move on. We have to give the two properties of the group to which element X belongs. Now, property 7. We talk about that. We say they are electronegative, and because they are electronegative, we can just put that down. Group 7s are halogens, they are electronegative. And because they are electronegative, they form a diatomic gas. Diatomic gas. Almost all gases are diatomic, except the noble gases. You can always also put that at the back of your mind. The other properties, you can talk about the group members, the halogens, the bromine, fluorine, chlorine, iodine, and astatine. So all these families are, they also form colored, they possess the characteristics of forming what colored pigment, or their nature, they are colored. You understand what I mean by that? There are also some other properties about them, but I think this is basic. It's very easy to know. The next one is for us to identify X by name. Number 17 in our periodic table is chlorine. I hope everybody knows this. So chlorine is the answer to X, which makes it very simple to know. You know the color of chlorine, greenish yellowish. So the next question is to write a balanced equation to represent the reaction between X and we have X and hot concentrated sodium hydroxide. Under the topic of chlorine and its compound, I have talked about this. For you to understand, I said chlorine combined with hot and cold alkali. So the nature of the reaction are quite different. So when we talk about hot concentrated sodium hydroxide with chlorine, we can say we have Cl2 plus NaOH. The major difference is just this. NaCl, that is sodium chloride, as everybody can see this and it's combined, because it is hot, NaClO3. So please note that if this is cold, it's not going to give us NaClO3, but rather NaOCl, sodium oxochlorate 1. So guys, can you hear me clearly? Okay, very good. So now sodium trioxochlorate 5. This is what you form for cold. Then for hot, excuse me, then definitely water is going to be liberated. And never you forget that on your right equation, you must balance, especially in standard examination like this. You have to balance it out. So let's try and balance this. Remember my logic, balance oxygen first. Chlorines are 2, then we have sodium. Let's start with sodium. This is 3 oxygen. Okay. So now I think this should be 3 2s are 6. So to complete 6 here, this is 1. We make this one 5. Then 5, and this will give us 6 oxo. No student can do that. And this should be 3 because hydrogen is now 6. So 3 times 2 should give me 6. And I think this should be balanced. Yes, it is balanced. Very good. It is balanced. Thank you. So we move to the next one. We are to explain why. Roman figure 1. Graphite is used as a lubricant. And diamond is used as an industrial tool. So because it's kind of, you can see from the marks, 7 marks, I think we have to explain. But the major reason for understanding sake is because of the nature of the structures of graphite. So graphite are arranged in, they are arranged in layers. I think that is the best thing you can write, arranged in layers. And you remember they have hexagonal shape. So because they are arranged in layers on each other, so that makes them a good lubricant. So please always have that at the back of your mind that they are always in planners and arranged in layers. Many times we do try to draw that. Maybe I can quickly do that because understanding really matters. What I mean by that is something like this. If you talk about graphite layers, they are always like this. Doesn't want to waste our time, just for understanding's sake. They have something like this. It always arranged on top of each other. Diagram not done to scale, just so it will continue in this manner. Let me just use pen to draw the rest. The next one, sorry about this. So the next one, we also come like that, like that, like that. Can you see this, my dear students? I hope you can see this. So you can say 6, 6. So the next one we come also like that. You have the same layer like that. So it continue in that manner. So what we see now is that each of these layers are now combined together by van der Waals force. Those are other things you can know. So which we call the weakest form of attraction between molecules. It occurs between dipoles and between We have another thing they call London dispersion force. I don't want to go into a level because we are only talking about UTME and WAHEC. So we should limit it to what we be asked. So guys, so layers are like this. You can see 1, 2, 3, 4, 5, 6, like that. So diagram not done to scale, but that is just what I want you guys to see on that. But this is what's actually cause graphite to be used as a lubricant because of what they form layers, and because of that, they are used as lubricants. Layers make them slide over each other because you can say, okay, they form layers. What am I saying? You know, when they are in layers, they will slide. And when you talk about lubricants, you know what we mean by lubricant. So because they slide over each other, they form layers and also slide over each other. So somebody is saying you are not hearing me, and others are hearing me. Maybe you check your network. Please adjust your network. So the next one says diamond is used as an industry. It's also the same thing as what we've talked about now. It's because of the shape of diamond. Remember, diamond is said to be the hardest substance known. So, and it's form octahedral shape. So about diamond, the reason is just because of, you can just say diamond form the three-dimensional shape. Diamond form three-dimensional shape. So which makes it hard? I think that is better. Which makes it hard. So it forms three-dimensional shape that makes it hard. And that is why it is used called two. So it's said in chemistry is one of the hardest substance, if not the hardest substance. So that is that. The shape is octahedral. Remember, graphite is a hexagonal. And I think we have some explanation on that in the education line too in our video course. You can watch that to understand it. The last one on this one, we have you have to write an equation to represent the reaction between aqueous, oh, this should be aqueous hydrogen chloride. Please, you can correct that. Aqueous hydrogen chloride and ammonia solution. So let us quickly write that before we go off on this. Our aqueous ammonia, and normally, you know, when ammonia reacts, ammonia is NH3. It is a base. We've talked about this time and time again with hydrochloric acid. They say the nature of reaction can be easily reversible. So you can say it's a reversible reaction. Remember that. And because it is reversible, it's going to give you one compound. That is ammonium chloride. In fact, this reaction we give you in laboratory will say white, dense fumes. White, dense fumes. So, and also we say this is a base. We've talked about that under acid, base, and salt, and this is an acid. Ammonia is a base, and the reason for it is because it has we call strong structure. It has what we call a lone pair. Remember that we talked about that. Then we talk about concept of Lewis acid, Brunstad-Lowry acid, and base. So because of the lone pair of ammonia, it's still a base. So this is the reaction, but remember we were told that it's aqueous. Aqueous hydrochloric acid. So because it is aqueous, that means the hydrochloric acid has the dissolved in the water. So you have to be very, very careful. So that means let's dissolve this ammonia in water. Everybody knows that. Please, all these soft things are very, very important if you are doing chemistry. You have to be careful. Not that this is not right. This is very correct. But it is better you write it the way examiner wants you to write. So if you want to do that, you can just say we have NH3 plus water. Everybody should know this. Give you NH4. My voice is not good. OH. So they solve that NH4 OH with hydrochloric acid. Everybody know this is now a form of reaction you call neutralization reaction. So from here, everybody know it's going to give us salt, and there's ammonium chloride and water. So this is acceptable because it follows the nature of the question. So that is that. And the last question, we are to name the type of reaction represented by the equation. So basically, the equation here is a neutralized. This is neutralization. As you know, neutralization is a reaction between acid and base. But if you are going with this reaction, this is just a direct combination reaction. Direct combination. So you can just type and send your questions. I will quickly attend to them. Then we have another one in the next slide. So I'm waiting for your questions. While waiting, we can look into the next one and see if we can quickly do that one too because of time. So let's see the next one too. Okay, fine. So guys, can you see the next one? I'm waiting for your response. Can you see, guys? Okay, fine. I can start. Excuse me. So we have to define saturated solution. We've talked about this under solubility, and we talk about the definition as the type of solution that contain exact solute. Should I write? Okay, fine, I'll write. So we get their solution that contains, somebody is saying, you cannot hear me. And almost every other student here are hearing me clearly. So check your network, please. Solution that contain exact solute. As it can hold, as it can hold, or you say dissolve at a particular temperature. In the presence of undissolved solute. We've done it. We've done the concept. So now it's just for us to write what we've learned. So that's that. And that will give you full mark for that definition. The second one is numerical. It's calculation. The solubility of potassium nitrate 5 at 20 degrees Celsius was 3 moles per dmq. If 67.0 grams of potassium nitrate was added to 250 centimeter cube of water and stirred at the same temperature of 20 degrees Celsius, determine whether the solution form was saturated or not at that temperature. So we are giving in bracket KNO3 is 101.0. So we can do that from also what we've learned. The solubility is in mole. We can convert it to gram so that we can solve. Remember, we say solubility in gram. Solubility in gram, or you say gram per dm cube, is equals to the 1 in moles, 3.00 times the molar mass, 101.0. So it's just like saying 101 multiplied by 3. And that is going to give us 303 grams. So that is the solubility in gram. So, but we want to know in gram per dm cube, yes. We want to know the amount that the total number of mass that is reacting at that temperature. So what I will do now is just I will compare the way we normally do in chemistry. We say 303 gram is dissolving in 250 centimeter cube of water. Then how many gram, I'm using X here, dear student, we dissolve in 1,000. Remember, from definition, amount of solutes that will dissolve in 1 dm cube. And the 1 dm cube is 1,000 centimeter cube. So the rest is just cross multiplication. This one will come and multiply this one will multiply this. And when we make X subject of formula, you are going to have 303 times 1,000. You divide that by 250. So that is what we're expected to do, and you can do that without wasting time. So we say this should be something like I'm not sure about this year 1, year 4. So this should be something like I'm trying to do that 7, 5, 7, 5. Okay, 7, 5, 8 gram. 758 gram. 758 gram. I hope this is correct. Okay, okay. Oh, look at me. I've made a mistake. I'm sorry about that. 303 dissolve in 1,000. Should be 303 dissolve in 1,000. How many we dissolve in 250? So this should be the way it should be done. So we make SOL formula here, the same thing. 303 gram dissolve in 1,000 dm cube and 1,000 centimeter cube. How many we dissolve in 250? So that is the way it should be. So we do 303 times 250, divide this by 1. So we can say year 1, year 4. So this is our 4 in 30 is 7. We keep 2. In 23 is 5. That's 20, we keep 3. 4 in 30 is that will be 8 approximately. 75.8 gram. So 75.8 gram, my dear student, is the answer to that. And that is telling us something. We've talked about this. Initially, they are 67.0 gram. Now, we have 75.8 is what that solution can hold. But now it is only 67.08 that is dissolving. So we say because it has less solute. Because of less solute, we say it is unsaturated. The solution can still hold up to 75.8. Only 67.0 is only reacting or being dissolved. So that is that. It makes it very simple. Let's look at the other ones. We have to distinguish between dative bond and covalent bond. We've talked about this one time again. It's the major difference between dative and covalent. I've used examples. I think I have sent videos to those of you that are on this paid course. I sent the video to you guys on how to really differentiate the visualization one, the one in which you see the reaction, you watch the way things are going in dative, which we also call coordinate covalent. Now, the major thing about dative and covalent is in dative, you are always going to be asked this. In dative, only one of the two participating molecule is donating. I've said this time and time again. We talk about both of them are sharing. They are sharing, they are not transforming like your ionic bond. So what you just need to write here is that the major difference here is that in dative bond, let's pray down. In dative bond, only one participating molecule is donating electron. So that's that. While in the other one, because of time, in covalent, both are what? Is donating electron to be shared, because it's important to write very well to attract the former. So while in this one, in covalent bond, both of them are donating the electron to be shared. So we talk about dative in, I talked about this NH4 plus, talk about ozonium ion in my example, which I've done for you guys before, you remember? So the videos are available if you still need for some of us that don't have the videos about the concept. Let me know and I can send it if you need them. So the next one here is we have to explain. Oh, somebody is sending smiling emoji. That is nice. I can see that you are you are getting it. Oh, that is good. That is good. Explain why sugar and common salt do not conduct electricity in the solid state. Excuse me, my voice is not that clear. Excuse me. So the reason why you can see it's kind of even cheap because the examiner actually make it simpler by saying solid state. So you know that conductivity does not occur in solid state. So we talk about free mobile ions, mobility of electrons. So if they are in solid form, you don't expect them to conduct electricity. So another thing you can just write, because if you like writing a lot of stories, everybody cannot think in the same way, but we're actually driving to the same point. That is why examiner easily know, they easily know if you are copying each other. That's why you need to know it and put it in your own language. So look at the sugar, common salt. Common salt is your NaCl. So in sugar, you can just say sugar basically are held by covalent bond. So and because of that, you can say the molecules, they are molecules. And because they are molecules, they are tightly held. There is no what? No free electrons to conduct electricity. So note that. Whereas the second one, you talk about sodium chloride. In sodium chloride, those ones are put together by your electrovalent bond, you know that, or ionic bond. So, but what happens is because they are in solid state, molecule, they are tightly held and what no valence what electron for what conduct it. No valence electron for conduction. So it is cheap question which by practice like this, you tend to know them. So the next one is we are to state the type of intermolecular forces present in hydrogen. I hope you can hear me. I hope I am audible. Okay. So hydrogen fluorides. In hydrogen fluoride, we talk about hydrogen and fluorine. Remember, still on bonding. So because it's still on bonding, hydrogen fluoride are tightly held together by what you call hydrogen bond. Say the type of bond that exists between hydrogen and high electron negative metal like fluorine, chlorine, oxygen, etc. are called what? Hydrogen bond. So the bond in hydrogen fluoride is hydrogen bond. And the second one here is asking about the type of bond in argon. So argon are held together by, some of you say London dispersion force. Yes, you are right. But you need to understand that this is basic. So it's better you just put the molecule of argons are held together by the weakest force, which we call van der Waals force. Van der Waals force. So the van der Waals force are broken down into two. Talked about that even in the previous slide. So this is this, and this is our keep questions because we know it, because we've learned it, because we are in the right place at the right. So the next is to consider the following compound with the following structure. Hydrogen is at the center. We have nitrogen and it's combining with our sulfur. Nitrogen is combining with oxygen. You can see both of them as nitrogen by their side. So here we are to say we are asked in which of the following compounds is hydrogen bond stronger? And you have to give your reasons this. So well, fine. It's not that hard because we can see hydrogen bond will be stronger in the second one because oxygen is more electronegative than sulfur. I've given you the chain of electronegativity. For those that are not having that, the common one is FON CLS, like that. It continues in that manner. So I've explained also in terms of periodicity and periodic table. So this is electronegative fluorine, oxygen, nitrogen, chlorine, sulfur, carbon, hydrogen, in that manner. So it's kind of very simple. Excuse me, the answer is because of the answer is that the second structure is more stronger in hydrogen bond because both of them are combined with hydrogen, and the reason is just because oxygen is more electronegative than sulfur. And the reason is because of the size again. You understand? Sulfur, you know the position of sulfur in the periodic table. And you know that of oxygen is 16 to 8. So oxygen has smaller size. So it's also going to have a high hydrogen bond. So these are simple things you need to. So the next one is I'm going to do that here. C is we have to state Dalton law of partial pressure. I think this is also a famous law. And if you want me to put it down, we've done the concept class on even for UTME, our crash course, the other program. I think we talk about Dalton law and stoichiometry and stuff like that. So when we talk about partial pressure, what the law is talking about is just relating the total pressure with sum of individual pressure. So we can write it, Dalton law of partial pressure state that the total pressure exerted by molecules by a mixture, let me just write it well, of gas, which is not reacting. Stop sending emoji, guys. Let's concentrate. It is not reacting. Is equal to the sum of individual partial pressure. So if you want to write the formula, you can just say P total is the sum of PA plus PB plus PC, and it continues till infinity. So that's what the law states, and that is what the examiner wants you to do. So the last question for today, we have for the morning section slide, we have if 200 centimeter cube of CO2 were collected over water at 18 degrees Celsius and 700 millimeter of mercury, we are to determine the volume of the dry gas at S. So standard vapor pressure of water is 18 degrees Celsius. 18 degrees Celsius is 15 millimeter of mercury. We've done this as well in concepts, and if not, you can still listen to how we solve this. Maybe we just take this corner and finish this. So finishing that, we can just use our general gas law. When we have something like this, is our general gas equation, which we remember P1 V1 divided by T1 is equals to P2 V2 divided by T2. So, but the major thing is the parameter. We need to know the parameter. The first pressure, it is P1. Now, look at P1. It was at 700 millimeter of mercury, but there is saturated vapor pressure. So, we say the total pressure is equal to sum of individual partial pressure. So from that, we can say, some people are saying they can't see me very well. Okay, let me help you adjust that. I believe you can see me now. And if you still can't see me, you will see me soon. Just don't worry. It is the nature of the camera. So now back to business. So with that, we can get the partial pressure of that one by subtracting the total pressure, 700, from the saturated vapor pressure, which was given as a. I can see your message. You cannot see me. Because of time, you should just manage. The camera is giving issue. How about this? Not clearly. Oh, okay. You will watch the recorded version of the last class if you are not seeing clearly. Don't worry, guys. But people are seeing. I don't know why some people are saying it. Focus on the question, please. I think it's the most important. So now this is going to give us 685 mmHg. So I hope you understand this. This is the most important thing. So the second pressure is at STP, standard temperature and pressure. And that is going to be 760 millimeter of mercury. Pressure of dry gas is always equals to the pressure minus the SVP. For those of you asking, that is the way we do it. That's the methodology we use. So note that. So the rest is just what you have here. You can see temperature T1, you have to convert. First temperature is 18. You know what to do. You add 273 plus 18. Oh, you can see me now. That's good. I can see that you can see me because I can also see myself. 273 plus 18 is what you have here. This should be, we have 1, we have 1, and we have 3. That's 11 Kelvin. Because I'm going to plug in all these one then. E2 is your standard temperature, which is 273 Kelvin. So the question asks for the volume. So whereby you were given one particular volume. So V1 was, I think V1 was given. Yes, we have 200 centimeter. So we are looking at each. So keeping it simple is the best thing. So now we just plug in that in the formula. Should I leave you guys to do that? Okay, quickly do that in seconds. I will not talk. I will just help you write out, and I'm waiting for your answer. I'm waiting. Let's see the first 10 people to solve. Just send it, I'll see. So it's just for us to plug in the values. I know you guys can do all this. Plug in the values, and you have the values on here. So if you do that, I'm trying to look at what you guys are sending. Okay. Oh, somebody sent an answer, 169.1. Okay, yes, because yeah, very good. You guys are getting the same thing, 169.1. So we can say the volume of the dry gas, which is what we are looking for. So I think you guys are correct. So everybody is having 169.1. So we are going to stop there, centimeter cube. So that is the right answer to that. Just plug in the values. And we stop here for morning section. The evening section, we are going to continue with the remaining part of the questions. As I told you, there are 4 questions, 2 morning, 2 in the night, the chemistry, physics, and mathematics. So that's that for the chemistry part. See you soon. Have a wonderful time. God bless.